Okay, good afternoon, everyone. This is Form 5 Tuesday group. Okay, nice to meet you all here again. Frankly speaking, I never expected to see you all online again Never expected one. The news come too sudden already. Okay, so what to do? This is a government policy, so we have to follow. Okay, so hope everybody stay strong and continue to struggle to study, understand. I know something not so good for you all. Your SPM dates are delayed and delayed again. Now you only sit for your SPM in the months of February. Okay, I think it's too long for you all in February, Huh? But all your lesson, the school teacher stopped teaching you all. The last day, your school day actually is 18 December. Okay, 18 December. 18 December officially the school teacher will stop teaching now. So that means you have almost 2 more months. You are on your own, okay? On your own to prepare your SPM before your SPM, okay? But so I think we cannot do much The date have been decided, so I think we have to get ready Understand? Okay. All right. So I have not using Zoom for a few months already. There's a lot of things I've forgotten already, so I need to catch up slowly. In fact, I only now renew my license Saturday night when I know the news. Or to go back to online class. I did not pay. I never renew the license. Since I opened the center already. So only last Sunday night I renewed the license again. Okay. Someone please off your microphone, can or not? Because I can hear the sound, the radio sound or what. Okay. All right, let's start our lesson now. Okay. Come, I share the paper with you. If you cannot see, so you let me know. Can see the paper or not? Can you all see? Dong Han can see or not?
Can
hear?
Can
See, can hear Okay. This Tuesday group, I want to know have we finished discuss question 11 Can you check your paper? Angel Tam, can you check your paper? Have you finished discuss question 11? Finish or not?
Today continue 11C.
11?
C.
D.
C cat.
Okay, C. Okay, come, let's look at question C. This one is something to do with periscope. Okay, so question A done already. B also done. Okay, now this one also done. This is something to do with fiber optic, right? Okay, now go to C. This one. Okay. So this one is 10-mark question. Okay, read the question, class. You are asked to investigate the features of optical fiber, okay, for designs of endoscope. Okay, endoscope means this one the doctor used to check internal organ this machine. Okay. This machine the doctor used to insert into your body to check your stomach, to check your heart, and so on. That is called endoscope. So the whole wire, this wire is fiber optic, okay? So it's fiber optic like that. So they ask you to choose now, okay? Table show the features of 4 types of optical fiber, PQRS. Now C. Sorry C long. Yeah, sorry. Thank you, Jeff. Okay, C now. It's supposed to start C. Okay, C is here. Okay, thank you, Jeff, for reminding me. Okay, now C. Diagram show a light ray passing through. You see the light going to glass, refracted, right? Surface of glass prism. Calculate the refractive index. Okay. When the light moving from the dense, less than to denser, you see this angle incident 30. Angle refraction is 18, right? So how to calculate the refractive index? What formula? What formula we use? Refractive index N formula is what? Okay, the formula is N equal to 1 over sine, N equal to sine I over sine R. Okay, let's see the, now the formula is here. Okay, this formula lah. Can you use this formula to calculate? Okay, remember, when you are using this formula now, you must take the bigger angle divided by the small angle. So I must be the larger one, bigger angle. Must use a big angle divided by the small angle. Understand? So it's sine 30 divided by sine 18. 30 is bigger, right? So sine 30 divided by sine 18. So you get the answer 1.62. Okay. So this one, I think no problem. Everyone can get. Okay, now go back to part 2 of the question. Okay. Determine the critical angle of the prism. Critical angle means the C. How to find the C? Critical angle lah. What formula lah? How to find critical angle C? Angel Tam, any idea or not? How to find critical angle C? Just now the formula was N equal to sine I over sine R. Now to find the C. What is the angle? What is the formula? Angel? Chong Han, any idea or not? What formula to use to find the critical angle? What formula? Yon En, are you there? Tan Yon En.
Yes, sir.
What formula to use to find critical angle?
N equals to sine 1 over sine C.
Yes, correct. Okay, so N equal to 1 over sine C. Use this formula. Okay, N equal to 1 over sine C, then sine C become 1 over N. You can take the sine C up, put the N down, so become this formula. Sine C equal to 1 over N. N is 1.62, so you get this answer. Okay. Sine C equal to 1 over N. Put in the N 1.62, the previous answer. So you get this lah. Okay. So it's 38.12. So remember, the critical angle is 38.12 because the next part that you're going to see this angle. Okay. The critical angle is 38.12. Okay, so now we look at the next question. Next question, you say what? What will happen to the refracted ray in the prism when it strikes on YZ? Okay, you see the diagram. When it strikes on YZ, YZ is here lah. Okay. So basically you need to draw a normal line. Okay, follow I draw a normal line here. Okay, my line not straight line. You all draw straight line. Okay, so you find this angle. You see this angle how big? Can someone please calculate how big is this angle? Okay, this one is 60. Okay, because 60, 60. So this one must be 60 lah. Then here you can find the value, right? Okay, this one 60. This one 62. So you can find this angle, then find this lah. What is the value of this angle? Can someone please calculate what is the values of this angle? E1. How big is this angle? E1.
30.
30. This angle 30. Okay, 30. Sure it's 30 or not? Okay, here 60. I cannot write. 60. This one is 90 minus 18, so here is 72, correct not? This angle is 72. Okay, then this angle is how much? 60, 72, so you find this angle. So how big this angle? 42, Jeff say 42, huh? 48 or 42, Lord, I do myself. Because you all type, okay? Why you all don't want to talk? Okay, okay, now I calculate myself. 180 minus 72 minus 60. So you get 48. Okay, then. Okay, so here is 42. Okay, 42. So get 42. So what is the conclusion then? If this angle is 42, so what will happen? The light will go out or the light come back? The light go out or the light come back? Okay, you have to see like this, Just now you calculated the refractive index, no, the critical angle, you see, 38.12. Critical angle is 38.12 only. So now your angle 42, which is bigger than the critical angle. Understand? Larger than the critical angle, 42 42 is bigger than the critical angle C. So what happened is total internal reflection happen now. Means the light will not go out, so the light will be reflected, come back. So the light will come back like this lah. Okay, reflected like that. Okay, are you all very ugly lah? So meaning that the light reflected inside. So the answer is total internal reflection happen, because he said what will happen to the ray so you say the refracted ray experiences total internal reflection. Okay, the answer. This one is in BN1, you all don't understand one. In English is the ray of the light experiencing total internal reflection. Okay, total internal reflection. Okay, write the answer. The light experiences total internal reflection. So they never ask you to explain, so never mind. Just for yourself to understand that. Because this angle 42 bigger than the critical C. The C was just now you calculated 38 point something, correct not? So when the angle bigger than the C, total internal reflection happen. Okay, understand? Liao Jingming, understand? Oh, no sound one. Besides, I don't like to teach online, no sound one. Nobody answer me one. Every time I talk myself, I answer myself, nobody answer me. You cannot hear me or what? Can hear me or not? Liao, can you hear me? Can hear me or not, you all?
Yes.
Can hear lah. You can hear lah, please answer lah, okay? Don't let me talk to myself only. Every time I talk to my computer only, I feel very boring like that. Okay, come, let's move on. Question number 12, okay? I think this one is something to do with transformer lah. This transformer, isn't it? Okay, transformer P and Q. Okay, what is the difference between here? You see voltage, power input all same. Oh, different no. This one 240. This one 110. Then NP. NP means the number of turns in the primary coil 2000. This one NP 500. And S 500. The secondary coil 500. So this one is step down. You see here, you know already. Primary coil 2000. Secondary coil 500 turns already means the number of turns less, right? It will step down. This one step down. Okay, make a note here now. Step down. This one, primary coil 500 turns, then secondary coil 1000 turns, mean more turns. So it's step up. Okay, step up. Yeah. So which transformer is step up? So you say transformer Q lah. So the answer Q. Q is a step up transformer. Explain the working principle. Okay, this is our question many times already. Okay, how a transformer work? 4 marks. Okay, very common question in the SPM. Okay lah, come. I explain one more time. You all listen. Don't write anything. I will give you the answer later on. You listen first. Okay. Like this, we cannot know where is the primary, where is the secondary, you know. Okay, never mind. Assume this one is a primary coil here. Okay, primary coil. So when the current go inside the primary coil, right? When the current flow, the AC current flow into the primary coil. First thing you write now, when current flow into the, okay, I think you better write straight away now. Okay, okay. You start to write now. When I say you start to write, I cannot show you the answer. The answer is in Bahasa one. Okay. When current flow into the primary coil, okay, write the answer. Flow into the primary coil. The coil and the core, okay, the core, this one, the soft iron core, the coil and the core is magnetized. It become magnet, okay. The coil and the soft iron core both are magnetized. When current flow inside, so the coil and the soft iron core are magnetized, okay.
DJ,
Right?
can you
Yes.
repeat?
Repeat. Why you all cannot hear me? Okay, I say it again. When current flow into the primary coil, the coil and the soft iron core are magnetized. Got it or not? Okay. Then varying, V-A-R-Y-I-N-G, varying magnetic field. Varying magnetic field is produced by the core and the coil. Varying magnetic field is produced by the core and the coil. Varying magnetic field are produced by the core and the coil. Okay? Got it already? Then next you write the magnetic flux link over to the secondary coil. The magnetic flux link over or cut over to the secondary coil. Cut over or link over to the secondary coil. Got it? Then next you say changings of magnetic flux. Changings of magnetic flux happen in secondary coil. Changings of magnetic flux happens in secondary coil. And last point you write, induced current is produced. Induced current is produced in secondary coil. Induced current is produced in secondary coil through the process of electromagnetic induction. Induced current is produced in the secondary coil through the process of electromagnetic induction. Got it, 4 marks. Okay, got the answer or not, everyone? Okay, can I get someone to read the answer? Okay, come. Apple. Apple lah. Apple.
Yes, teacher.
Apple lah. Can you read out your answer slowly and loudly for everybody? Okay, please, Apple.
When current flow into the primary coil, the coil and the soft iron core are magnetized. Varying magnetic field is produced by the core and the coil. The magnetic field link over to the secondary coil. Changing of magnetic flux happens in secondary coil. Induced current is produced in secondary coil through the process of electromagnetic induction.
Yes, thank you very much, Apple. Okay, very good. Okay, thank you. Okay, everybody got the answer now. Hey, better get ready, you know. This question may come out one, I tell you many times already in the SPM. The working principle of transformer. Make sure you know how to write. They will ask you to explain how the transformer produce a current. So remember that. Okay, next. Next one, I think is a little bit. Diagram shows circuit consisting of transformer. Transformer is here. When you see these two lines, means got two coils, this is transformer. From here, you know already this is step down. Because here got more turns, this one less turn, so it's step down. Okay. Ammeter is here. And two light bulb, we have two light bulbs here, 12 volt, 24 watt, 12 volt, 20, same one. Okay. The ammeter here, 0.5 ampere. Please jot down here 0.5 ampere. And both bulb line up normal brightness. Okay, what is the meanings of line up normal brightness there? You must know, you know. You can ask you one, you know. Line up with normal brightness means the bulb here receive what they want. Receive 12 volt, 24 watt. Receive 12 volt, 24 watt. When you receive the required power supply, right? So the bulb will line up with normal brightness now. If the question asks what is normal brightness, you must say now the bulb receive the required voltage supply. Okay, 12 volt, 24 watt. This one also receive the same. Okay. Okay, now question. What is the output of transformer? Okay. How to answer? No calculation. Can you tell me what is the output voltage of the transformer? Kelvin, Kelvin Chi, can you tell me what answer? What is the output voltage of the transformer? No calculation.
24.
24. Why 24?
12.
Yeah, 12. Okay, meaning that this bulb receives 12. This bulb also receives 12 because light up normal brightness, right? But they are parallel. Parallel means the voltage here and here same one. So meaning that the output voltage here is 12 volt. Okay, 12 volts. They are parallel means both get the same one, 12 volt. Okay, so the answer is 12. Okay, so okay, calculate the efficiency. Efficiency formula is what? Okay, efficiency. Okay, I say you listen now. Efficiency, the formula is output power divided by input power times 100%. Output power divided by input power times 100%. Okay, now it's here lah. But this one in Bahasa one, don't know whether you understand or not. No. Okay. Yeah. Input power is VI, voltage 240, I 0.5. This is now given, right? And the output voltage 24 plus 24. Okay, remember now, the power 24 watt, right? You just add up. You don't care parallel or series. For power, you just add up. Add up 24, 24, so become 48. So remember that. For power, you don't need to say whether it's series or parallel one. No, you don't need one. Just add up 24 watt, 24 watt. Okay, add up only the power, only the wattage must see parallel or series. Power, no need. 24 watt plus 24 watt, so 48 watt. Okay, so output is 46, input 120 times 100%, so you get 40%. Efficiency is 40%. Understand? Everybody understand? Nobody answer me. Very Christian me lah, like you like that.
Yes, sir.
Okay. At least Kelvin answer me. He pity me lah. Thank you, Kelvin. Okay, come next. Next question. Okay. You're asked to choose. See the question. Slowly, because this Zoom, I forgotten already. A long time never use it already. Okay, now transmissions of electricity throughout national grid network. This one is another favorite question. Use high voltage cable. You are assigned to study the characteristics of cable which is suitable as a transmission cable. So PQRS, so you choose one. Okay, there are 4 features here. No, resistivity, the density, the cost, the rate of thermal expansion. Okay, I think this is very simple. Resistivity, you choose high or low? Jeff, the cable resistivity you choose high or low?
Low.
Yes, low. Must choose low. Okay. Density, what about density? Angel Tam, density, you choose high or low?
Low.
Low. Okay. Also, we choose low because we want the cable to be lighter. Because the cable going to hang very high in the jungle, isn't it? Very long. So you need it to be very light. What about the cost? Cost must choose high or low. This one I think very common sense. Normally we choose a low cost one, cheaper, right? Because the cable is lasts a few hundred kilometers, very far. So we choose low cost. Okay, what about the last one? Rate of thermal expansion. What is the meaning of thermal expansion? What is the meaning of that? 夏兴义出来一下可以吗？夏兴义出来一下啦，你的头出来一下。OK， 我问你 ，rate of thermal expansion 是什么来的 ？Thermal expansion is what? What is that? Thermal is heat, is hot. Expansion, expand okay? So meaning that when the wire getting hot, it expand. When the wire cold, it will contract. So you want the rate thermal expand to be high or low? Xia Xingyin? You want the wire to low. Yes, we don't want the wire to expand. Because when hot you expand, when cold contract, so the wire, the cable, very easy to break one, so no good. That's why we choose low rate of thermal expansion. So finally, which one is the answer? Resistivity must choose low. I think this one not low, right? Density also low. I think this one is power 3. Cost medium. But rate of thermal expansion, only one is low. Okay, I think no choice. We have to choose this one. Okay, Q. Okay, let's check the answer now. Yes, Q. Okay, come. You answer in the table. This one is in Bahasa. I translate for you. Okay, come. Right? Here you put suggestion. This one is your explanation. Okay, first answer you write low resistivity. Okay, the resistivity low. Low resistivity. The reason is reduce power loss. reduce the power loss. Because when the resistance is high, when you send the voltage, right, the current, so it will cause power loss, so you can reduce the power loss. Okay. Okay. Second suggestion, low density. Okay, ketumpatan rendah mean low density. Okay, the reason is the cable is lighter. Okay, lighter. Cable is lighter. And third, you choose low cost. Okay, low cost. Okay, reason is the cost of the project will be lower. Cost of the project is lower and can save costs. Cost of project is lower and it can save costs. And the last one, rate of low rate of thermal expansion. Low rate, okay? Low rate of thermal expansion. Okay, the reason is the cable not easy to expand, not easy to expand when the weather is hot. The cable not easy to expand when the weather is hot. This avoid the cable from breaking. Cable not easy to expand when the weather is hot. This avoid the cable from breaking. Okay. And the last one you choose Q lah. Then you repeat the reason now. You write yourself lah. The most suitable cable is Q because you repeat again. Blah, 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 blah. Okay. Got it or not? Tisna, do you get the answer?
Yes.
Okay, good. Jiafan, do you get the answer?
Yes.
Okay, good. And Tang Mingyi, got the answer or not? Tang Mingyi?
Yes.
Okay, Lim Curvy, got the answer? Lima.
Yes.
Ken Ming, got all the answer or not? Ken Ming?
Yes, yes.
Okay, good. Okay, so I think we have finished already. This one finished, huh? All right. So now come back here. Okay, the next paper I want to discuss with you is paper 3, experiment question. You got print out the paper or not? Actually, very sayang, the paper I printed already, I left in the center part. How to keep you all now? The paper printed already is in the center. But cannot, I don't want to ask you to come and take, then later create problem. Okay. Chan Ching-yi asks, normal brightness is about receive the required voltage. Require voltage. Chan? When the bulb receives the required voltage and power, you can write that lah. Receive the required voltage and power. Chan, got it or not?
Yes, sir.
Okay, all right. Any more question to ask? Any more? Any question to ask here or not? Tan Yun Si, any question?
No.
No. Tan Wei Yi, any question?
No.
No, all no question one. All very good one. What Ming, any question?
No.
No. And where's your good friend Avril? Avril Ong, anything to ask or not?
No.
No. Oh, no. Tai Hua Kai, any question? Hua Kai?
No as well.
No. Any question or not?
No.
Okay. Raymond, any question?
No, sir.
Kelvin, any question? Kelvin Chi?
No, sir.
Oh, no question. Very good. Tai Chuan He. Any question?
No, no.
No question. Tan Chai Liang. Any question? Tan Chai Yong, Chai Liang.
No
Question.
question, sir.
Okay lah. Then we move on paper 3. Okay, come. I share the paper with you all now. Give me a little bit time. Okay, hold on. Okay. Can hear me or not, everyone?
Yes.
Can. Okay, come. I share the paper with you all now. Okay, I want you to look at the experiment question first, okay? Get ready your foolscap paper, okay, to write the answer. Foolscap paper, the experiment question. This one. Question 3, question 4. Can see the question a lot? Raymond, can see or not?
Yes, sir.
Can, Okay, the question is, okay. Diagram show a boy skateboarding. Okay, you see the boy skateboarding now. So normally it's like this, or this boy go up, then it slide down, granite with a different height. Okay, here now it go up slower, then it come down. This one go up very high, then it swing down. You see now, when it go higher, when it come down, it become faster. Correct not? This one slower. This one, the position is higher, so when it come down, it will go faster. So meaning that this diagram show what relationship like. It must be relationship between two things, One definitely is height. This one lower. This one higher. The height. Another variable is what? Chuan He. One is a height. This one low. This one high. Another one is Chuan He lah. Kai. Chuan He. Another one is what? One is a height different. This one low. This one high. Another one. Kai. Another one different one is what?
Not sure, sir.
Now might just try. Someone give the answer already. Gravitational potential force. Jeff. Jeff, you go too fast already. No, actually just say the speed or the velocity. When you go higher, you come down from higher position, right? Your speed is higher. When you go down from a lower position, your speed is lower. Understand? So meaning that this diagram show the relationship between the height and the velocity. The height with the speed. Understand? It's a relationship between the height and the speed. Okay. Now, I'm not sure your technique, you must learn like this. You go to section C, you see what the apparatus given. You see here. You see what they give. They give you such a trolley. They give you trolley already. Wooden block. You already know what is that. Because the trolley, you need to put a piece of wood, right? The trolley you put here. Then you put a wooden block here, to change the height, the wooden block. Understand? To change the height. So you see lah, you adjust the height, you see the speed, how fast the trolley go down. Okay, that's all. I think very obvious. The wooden block is for you to put here to change the height of the runway. So maybe first one, you put one piece. So let the trolley go down. You get the speed now. Use a bigger tape to calculate. Then you put 2 pieces of wooden block, it becomes higher. Then 3 pieces higher. When it higher, definitely it go faster one. Understand? So it's very obvious, confirmed already. The experiment is this one. Hey, remember now. If not sure now, you go where? Go where to see. Kelvin. Kelvin,
Yes.
if you are not sure the experiment, you go where and confirm? Yuan En, Tan Yuan En, if not sure, you go where to confirm?
Section C.
Go section C, see the apparatus given to confirm the experiment. Understand? Hua Kai, understand?
Yes, sir.
Okay, now answer the first one. What is in front? In front, how to write? Hey, until now, everybody must know how to write in front already, now. How to write in front? In front must use a keyword depends. What depends on what? Okay. So in the case of this question, Tan Yuan Si, can you tell me what depends on what? Tan Yuan Si?
Velocity depends on height.
Yes, correct. Velocity of the trolley, velocity of trolley depends on the height. Okay, depends on the height. Velocity of trolley depends on the height. Okay, And next one, hypothesis. Hypothesis means the relationship lah. You must know one. What relationship? Okay. Okay. For this, I do call name lah. JY. JY is who? Tan Jie Yin. Are you Tan Jie Yin? Tan Jie Yin, you 在吗? Tan Jie Yin.
Yes, sir.
Can you hear me or not? Tan Jie Yin?
Yes.
Tan Jie Yin, can you tell me what is a hypothesis here? What should be the hypothesis? The greater the height,
the greater the velocity.
yes, correct. The greater the height, the higher the velocity. Okay. The greater the height, the higher the velocity. Okay, that will be your hypothesis. Okay, next, M. How to write M? I must call name lah, I don't call you, you're going to hide there forever, never come out one. Kian Ming, who can Ming? Can you tell me the aim, who can Ming?
To investigate the relationship between the height and the velocity.
Yes, very good answer. Kian Ming, can you repeat one more time?
To investigate the relationship between the height and velocity.
Yes, correct. Very good. Thank you, Kian Ming. Yeah. Okay, next one is variable. Okay, variable. You see this diagram? You see the diagram? What is a manipulated variable? What is a manipulated variable? Fu Huiwen. Fu Huiwen, Fu Huiwen, can you come out? Can you come out or not? Fu Huiwen, okay, she cannot talk, but she can type. Fu Huiwen, what is a manipulated variable? MV, manipulated variable is what? Okay, I see what you type. Who wants to say height? Yes, correct. So you cannot just write height. You must write manipulated variable. You write height, then comma h. Must have a symbol h. Okay, h. Height is h. Okay, manipulated variable is height, comma h. Okay, next one. Responding variable is what? What is responding variable? Okay, let's hear from Nicholas. Nicholas Gu. What is the responding variable? Nicholas?
Velocity v.
Yes, correct. Velocity v. Okay, must put the symbol v. Velocity v. So manipulated is a height. Responding is a v. And one more very important one, last one. What is the constant variable? Constant variable in this experiment now. What must be constant? Very important, no? What must be constant? I see how you all answer. What must be constant here? What must be constant? Okay, Pong. Okay, Pong Yong En. 他躲在后面。Pong constant variable 是什么？
Mass of a trolley.
Yes,
Mass of a
correct.
trolley.
Yes, correct. Mass of the trolley means every time the trolley mass must be the same. Mass of the trolley, 1. I think got one more important one. Besides mass of the trolley, there's another one, constant one is what? It's something to do with this runway. What is the answer? Come, let's hear from Avril Ong. Mass of trolley must stay constant now. One more thing you think must be constant one is what?
Surface of the board.
Again?
Surface of the board.
Yes, correct. The conditions of the surface of the runway. The runway, the condition of the surface must stay constant now. Cannot be sometimes smooth, sometimes very rough, cannot. Understand? So you must say conditions of the surface of the runway. The one must stay constant. Okay, the condition of the surface of runway. Yeah, Jeff give another one. He say the length of the runway. The length must also be the same. Yes, correct. Length of the runway. This runway, the length must be the same. Every time must be the same. Correct. Jeff, thank you. Okay. The length of the runway must stay constant. Okay. Yeah. So this one finished already. Okay. Next one will be the list of apparatus. Okay, come and show you the answer. I don't know got the answer here or not. It is in BM1. Okay, I read out your copy. I see the Bahasa one to give constant variable is what? Mass of trolley and the length of the runway. Length of the runway must say constant. Okay. And the apparatus first is a runway. Landasan is runway. Ticker tape. Ticker tape. Ticker timer. This is ticker timer. This is ticker tape. Ticker timer. Runway. Ticker tape. Ticker timer. Wooden block. This one is wooden block. Meter rule. Power supply. AC power supply. AC power supply. Connecting wire. Connecting wire. And trolley. Then I think the PM one you all can understand a little bit one. Runway. ticker tape, ticker timer, wooden block, meter rule, power supply, AC power supply, connecting wire, and trolley. And last, the diagram. Please take down the diagram. Draw the diagram. The trolley is here, the runner is here, the wooden block is here. So connect to the power supply. This one is a ticker tape. Ticker tape. This is a ticker timer. Ticker timer, ticker tape. Runway, power supply, connecting wire, and so on. Okay. Copy the diagram. Okay. Please learn how to draw. Okay. Don't be too smart. You can take your camera, you shoot a picture, then no. Then like that, you never practice yourself, you know. Don't say Mr. Tan so stupid. I to draw. No, because I want you to practice. Understand? Practice, draw the diagram on the paper. Okay. Please do it. Yeah, finish already?
No.
Not yet. Okay. Now might take your time with you. Jeff, go and take myself a drink. Okay, go. Please go ahead. Okay. Okay, finish or not? Job, finish or not? Job,
Yes, sir.
job, finish.
Hmm.
Liao Jingning, finish or not?
Yes.
All finish. Okay, come. We move on to procedure. Okay, procedure. First, write the normal one. You write. The apparatus and material are set up as shown in the diagram. You see here, susun rata seperti raja di atas. The apparatus and material are set up as shown in the diagram. Yeah? Got it or not? Okay, second step. Second step you cannot follow here. You must say, you must put the wooden block to make this runway how high. So you say, one wooden block with the height 10 cm. A wooden block with the height 10 cm is placed under one end of the runway as shown in the diagram. A wooden block with a height 10 cm is placed under one end of the runway as shown in the diagram. Got it or not? Meaning that you start with 10 cm, understand? The height 10 cm. Then you say, third point, the ticker timer is turns on. The ticker timer is turns on. And the trolley is released. The ticker timer is turns on and the trolley is released to move down to the end of the runway. Move down to the end of the runway. Okay, finish. Next, the ticker tape is removed. The ticker tape is removed to calculate the velocity of trolley. The ticker tape is removed to calculate the velocity of the trolley. Okay, next step, do what? You already finished one experiment already. You let the trolley go down, take out the ticker tape, you calculate the velocity already. Next one is do what? Next one do what? Pong. Pong Yong En, right? Next one do what? Pong Pong 出来啦 Pong. Next one do what? Pong. Next one must do what? Pong. You already finished the first experiment. Next one do what?
Repeat the experiment.
Yes, correct. Repeat the experiment. Okay. So you say the experiment is repeated by increasing the height of the runway. The experiment is repeated by increasing of the height of the runway to 20 cm, 30 cm, 40 cm, 50 cm. Okay. 20, 30, 40, 50 cm by adding more wooden block. You must say, no, how? You must say by adding more wooden block. The experiment is repeated by increasing the height of the runway to 20, 30, 40, and 50 cm by adding more wooden block. Okay? Yeah? Got it or not, everybody? Ang Xiao Hui, got it or not? Ang Xiao Hui?
Yes, sir.
Okay. After that is your tabulation, the table lah. Okay, table you can follow here lah. Okay. The table here is a height. This table is not correct. Though. You put height must slash height. You must put h slash cm. Even the marking scheme also wrong one, you know. Here you must put height h slash cm. Okay. Height h slash cm. Here velocity v slash, what is the unit for velocity? Must be you are using cm, right? Centimeter per second. Okay, centimeter per second. Don't write like this. You must write velocity v slash cm per second. Okay, and then this one you took just now. We said 10, 20, 30, 40, 50 lah. Okay, you can write. This one no need. And the last one will be the graph lah. So is velocity against the height. Okay, don't terbalik no. Responding variable must be here. Manipulated variable must be here. Understand? Yeah. Finish. Wei Xiang. Tan Wei Xiang. Finish or not? Tan Wei Xiang.
Yes, sir.
Finish. Okay, come. We look at next question, number 4. This question. Okay, study the question first. Okay. Diagram show 2 identical remote control car. Okay, these 2 are the remote control car. Okay, A and B are racing on the track. Diagram 4.2 and 4.3. 4.2, 4.3 is here now. This one is 4.2, 4.3. What is this? Got magnet. This one got magnet, coil, and measure. This one got more magnet. Okay, what is this? Never mind. We go and see first. Diagram 4.2, 4.3 show the cross sections of the motor used by A and B respectively. The motor. So the motor is here. Actually, is here. This is a motor. Okay. So the motor is using a magnet, using magnet make it rotate. So you are using the magnet. Turbine. Motor and turbine same lah. Turbine is the one turning, turn, right? You will turn one. Okay. So here the purpose you see here, you have coil, you have wire, you have magnet too. So you have the magnetic force will make this thing to turn. So the power go in, the electric go in, so come out. So when the electric go in, so here we become magnet. So magnetic field and magnetic field, when opposite direction, it will push so it will rotate. Understand? And then here you have coil, more or less the same, but you have stronger magnet. More magnet here, stronger. Okay, stronger magnet. So the magnetic force is stronger. So it can make this thing turn faster. turn faster means that the car can go faster, no? Correct not? So this is, okay? This one is car B, this one car A, I suppose. So the cross section used by car A, car A is here, this one, 2 magnet only. Okay? Car B got more magnet. So that's why you see car B go faster. This car goes slower, correct not? Okay? Car A slower because I think the magnet not strong. That's why this thing will cannot turn very fast. This car go faster because you have stronger magnetic field. So you have a stronger magnetic force to make the thing to rotate so you can go faster lah. Okay, okay, now, what is the inference here? Inference. Inference, this one is something to do with what? So what is the inference here? What depends on what? What depends on what here? Ang Xiaohui, can you try? Ang Xiaohui? What depends on what? Ang Xiaohui? In this question, what is depends on what now? Ang Xiaohui? Okay, now the first one you can write what you see. For inference, you can write. So you can say the speed of the car. The speed of the car depends on the strength of magnet. The speed of the car depends on the strength of magnet. This one is magnet. Depends on the strength of the magnet. Yeah. Here got more magnet, definitely the magnet stronger, right? When magnet stronger, like you can go rotate faster, so you go faster. Okay, that one is inference. Then your hypothesis is what? What to write for hypothesis? Hypothesis, what to write? Job, what to write for hypothesis?
The stronger the strength of magnet, the faster the speed of car.
Okay, I know why you give this answer. Okay, class, remember when come to a place, you are not so sure. You are not so sure what to do. Every time you go to C to check what are the things given first. Okay, you go to C and see. They give you the C-shaped iron core. Okay, this one iron core, copper rod. You are given the copper rod, the copper wire for what? Copper rod. Okay, the copper rod actually for you to do something like that. This one, okay, come now. Roughly, I tell you what. The C-shaped iron core is like this one. C-shaped one, the iron. And that one are the shape, okay. C-shaped iron. Okay, then this copper rod is for you. Actually, you remember the experiment or not? You put 2 wires, connect to the power supply, right? Then the wire, copper rod, you put here. You hang it here. Okay, so you put magnet here. Of course, you need to use magnet lah. Magnet you put here. Put magnet here. Okay. Here, bottom here also put magnet. Okay, magnet. When you on the power supply, then the force to push this wire to move one, isn't it? When the force is stronger, so the wire move further lah. So this wire will be pushed. You remember the experiment or not? So meaning that by you want to see the force, okay, the force So this wire move how far, you measure how far you move lah. Okay, so your hypothesis is like this lah, okay? Hypothesis you can write. The stronger the magnetic field, the stronger the magnetic field, the stronger the magnetic field, the further the distance moved by the copper rod. The stronger the magnetic field, the further the distance moved by the copper rod. The copper rod. One is hypothesis. All right, next one. Okay, next one, come now. Come. C, next one, C. The aim is to investigate the relationship between the strength of magnet and the distance moved by the copper rod. You refer to your hypothesis, to investigate the relationship between the strength of the magnet and the distance moved by the copper rod. No, the diagram is here now. Class, you see here. Come now, let me explain first. So this is a C-shaped iron. The copper rod is here. So you have two wires connect to the power supply. Then you put magnet here, one piece, one piece. You on the power supply, there will be a magnetic force, right? Push the wire go. Or go out, go in also can now. Okay, go out Then here is go out. So you measure distance D1. After that, you put more magnet here. You put two pieces here. Just now one piece, one piece. Now you put two pieces magnet here, two pieces here. So the magnet becomes stronger. When magnet stronger, then you see how far they move. I'm sure when you put more magnet here, stronger magnet, this copper rod will be moved further distance because the force is stronger. Understand? Okay. So aim done already. Okay, variable, manipulated variable is the number of magnet. The numbers of magnet, how many pieces of magnet you put. The numbers of magnet. Responding variable, distance moved by copper rod D. And the constant variable is current. The current here must be the same. Every time the current must be same. The one different is the number of magnet. Okay. A number of magnet here you put N, capital N. Number of magnet manipulated. Responding variable is the distance moved by the copper rod T. And constant variable is the current. The current here must be fixed. Cannot change the current. Okay. Apparatus and material copper rod, you see this diagram copper rod, magnet, C-shaped iron, ammeter, dry cell, rheostat. Okay. And copper track. Copper track means these two pieces of wire copper track. Okay. Two pieces You don't write copper track, never mind. You just write copper wire also can. Copper wire. These two are the copper wire. This one is a copper rod. Okay, these two pieces are magnet. Then after that, take out the diagram. Stay focused, everyone. Okay. You really have to prepare for your SPM now, Really take, okay, practice lah. Practice to answer, Draw the diagram properly. Focus, okay, everyone. Focus, Okay, done or not? Hoa Khai, finish or not? Hoa Khai,
Haven't.
Evan, okay lah. Angel Tan, finish or not?
Not yet.
Not yet. Apple, finish?
Yes.
Apple very fast, Isna, finish or not?
Not yet.
Not yet. Okay. Lim Curvy, finish?
Haven't.
Evan, okay. Carry on, carry on. Chai Yong, finish or not? Tan Chai Yong, Tan Chai Lian, finish? Evan. Okay, carry on, carry on. Eric? Erica, you Eric?
Yes, finish.
Finish already. Good. Okay,
Yes.
Eric. Jeff, finish? You want? One Emma?
No.
No, okay lah. I give you a little bit more time now, okay? Run, Jeffrey. Okay. 1 more minute, sir. Huh? I'll give you 1 more minute. Okay. Okay, come. Everyone. Okay, come. Procedure now. Okay. Procedure, if I ask you to write yourself, you can write or not? Huh? Tisna. Okay, Tisna. Tisna, come out, please. Tisna.
Yes, sir.
Tisna, can you tell me first one what to write for procedure? First one. First one, what to write? Lim curvy. First one, what to write? Lim curvy.
The apparatus is set up as shown in the diagram.
Yes, correct. The apparatus and material are set up as shown in the diagram. Okay, first part. You don't need to explain now. You just say set up as shown in the diagram. Okay. Yeah. Then second point. Okay, second point. I explain. Now you listen. We started using 2 pieces of magnet. One up here, one up. Use 2 pieces of magnet. And as you say just now, the current must fix, right? Okay, I think like this lah. So we say like this, 2 pieces of bar magnet, 2 pieces of bar magnet placed on the C-shaped iron, 2 pieces of bar magnet placed on the C-shaped iron as shown in the diagram. Then, next, the current is adjusted to 1 ampere. We fix the current to 1 ampere lah, or you say the current is fixed to 1 ampere by using a rheostat. Use a rheostat to fix the current to 1 ampere. Okay. Okay, next. The distance moved by the copper rod T1. The distance moved by the copper rod T1 The distance moved by the copper rod T1 is measured using a ruler. Okay. So that finished the first round of experiment now. So the rest are repetition now. Okay, repetition you write yourself. I want you to write yourself. When I call your name, you give me the answer now. Can you write the repetition? Repetition is like this law. You repeat the experiment, but you put just now 2 pieces. Now you put 4 pieces, 6 pieces, 8 pieces, more and more now. You must be double one, 2, 4, 6. You put a magnet, more and more magnet, you see what happens. Huh? You repeat the experiment. Okay, write the repetition. Yuan it's okay, don't worry. If your internet Wi-Fi not so good, never mind lah. You go out and come in again lah. Don't panic, it's okay. I understand one lah. Okay, you go in, come in again. If really cannot get I will upload the video. You all can see the video later on lah. Okay, don't worry, it's okay. You're not, no need to worry. Okay, finish or not? Finish your repetition now. Okay, come. Let's hear from Selina. Okay, Selina 可以出来吗？
Yes.
Selina, what's your repetition? Can you read out your repetition?
The experiment is repeated by using 4 pieces, 6 pieces, 8 pieces, and 10 pieces a minute.
Yes, very good. Okay. Read one more time slowly lah. Too fast lah, Selina.
The experiment is repeated by using 4 pieces, 6 pieces, 8 pieces, and 10 pieces of magnet.
Yes, okay. Thank you, Selina. Okay, that's all lah. So that will be your repetition. Okay. All right. After that, next one, tabulation, the table. Table is here, lor. Here is numbers of bar magnet n. So you put 2, 4, 6, 8, 10. Exactly like what Selina said lah. 2, 4, 8, 6, 10. And here is a distance moved by the bar copper rod. Distance traveled by copper rod dcm. Okay, Okay. So last one is a graph. Graph here is I think it's wrong again. The graph is wrong, The answer given, this one, the answer also wrong and wrong. This one is wrong, don't follow. This one is wrong, all wrong, the answer. Here supposed to be n. Okay. Here supposed to be the distance d. Yeah. This one cm. Number of magnet n, no unit, okay. Responding variable is a t, so t must be here. Remember, no, some students will make mistake one. No, when you plot the graph, y-axis must be responding. Manipulated variable is n is a x-axis. Okay. Okay, finish. Okay, I think finish now. Oh, okay, come. Okay, now we look at question number 1. Question 1, read the question, class. Okay, this question, student carry out experiment to investigate the relationship between the pressure, so highlight pressure, and the force, relationship between pressure and the force. Apparatus setup as shown here. So here you put 100 gram. So this one will be the force lah. The weight, how heavy here you put, this one is a force. And then the pressure is, you see how deep this thing sink into the plasticine. Okay? Depth of sink, depth of how deep this thing sink into the plasticine is actually the pressure lah. When you go deeper, you sink deeper, mean the pressure is higher lor. Understand? So meaning that this experiment is by adding more and more load, then you see how deep this thing sink inside. Okay, now you say what? Experiment, start the experiment by using slaughter weight 100 gram. The depth of den of the plasticine measured by using vernier caliper, not using ruler, using vernier caliper to measure, shown in the diagram lah. So you have 200 gram, 300, 400, 500, and so on. Okay, now the diagram is here. First one shows zero error. Okay, nothing here, you don't put anything, but the 2 0 are not point to each other, means you have zero error. Can you determine what is the zero error here? This one is zero error. You must know, what is the zero error? Okay, the zero error you see now, when this 0 is in front, this one behind, means negative. This one is negative, zero error. Then you find the line, which line same? So I think this one is the same, is here. This one with what number? What number there? 5, 6, 7, 8. This is number 8, right? Then the zero error, how to read? How to read the zero error? If negative zero error, what you do? What is the zero error here? Okay, I want to ask from you all. Eric, line number 8 are same. So how to read the zero error? Eric? Eric, how
Yes.
to read the zero error?
See the zero first.
Like that one. Then can you tell me what is a zero error here?
Negative 0.02 cm.
Yes, how you get negative 0.02?
Because of the what to say?
Okay, like this lah. Because of line number x, same right? So it's negative. So when this is negative 0 error, you take 10 minus x, so you get 2. So the answer is negative 0.02. Negative, 0.02. Okay, negative 0.02. This is 0 error. If negative 1, you minus from 10. If positive, so you read direct, understand? You read like this one 8, 0.08. But this one is because of negative, this 0 in front, you cannot read direct, so you minus from 10. 10 minus 8, so 0.02. Okay, Okay, next, get this reading. 1 Newton, you put 1 Newton force. So what is 0? What is reading here? Get this reading. 0, 1, 2. Here is 2 already. So the reading must be 2 point something now. Okay, 2 point. No, not 2, sorry. 0, 0.1, 0.2. Here is 0.2. Okay, 0.2. Yeah, 0.2. Then you find the line, which one same? So this one. This is 6, right? So the rating is 0.26. So you write the answer here. 0.26. Yeah, 0.26. 0.1, 0.2. This is number 6, 0.26. And then the correct answer, you do correction now by minus the 0 error. Minus negative 0.02. So here become 0.28. Okay. Minus negative 0.02 become plus, so 0.28. Okay, the rest of the diagram, go and get the reading. Do it now, everyone. These are what reading. And these two, okay, get the reading. Get the reading, do the correction, get the reading, do the correction. Yes, Chan must write the unit. The unit for vernier caliper is centimeter. Write the unit centimeter. Okay, must write centimeter, everyone, please. This one write centimeter. cm, okay? Write the centimeter. Okay, 1.5, 1.6, 1.7. Okay, 1.5, what answer? 心肺, lim 心肺, what answer? lim 心肺1.5是多少？ 1.5, what answer? 心肺
0.60.
0.60. Yes, correct. 0.60. Then after you do correction, it become what?
0.62.
Yes, correct. Okay. Tan Wei Yi. What is the answer for 1.6? Tan Wei Yi?
1.04 cm.
1.04. After you do correction?
1.06 cm.
Yes, correct. Okay, very good. Okay, next one. 1.7. Tai Hua Kai, 1.7. What answer?
1.49.
2.4. Yes, 1.49. After you do correction?
1.51.
Yes, correct. Okay, so done already. I've got one more, 1.8. The 1.8. Ang Xiao Hui, one answer. Ang Xiao Hui, 1 point. This one?
1.85 cm.
Yes, 1.85. After you do correction?
1.87 cm.
Yes, correct. Okay, so everything correct already, Okay, leave it first, and now we answer the question. Okay. What is a manipulated variable? So manipulated variable is what? Yuan En, what is a manipulated variable?
Force applied.
Yes, force, because it's all given Newton, might see 5 Newton, right? So it's force applied, correct? Then what is a responding variable? Tan Yun Si, what is a responding variable? Tan Yun Si?
Depth of plasticity.
Depth of?
Depth of plasticity.
Yes, correct. Depth of 10 of the plasticine, D. Okay, must put D now. How deep is sink into the plasticine, D. Okay, constant variable, very important. The constant variable must be what? What must be constant here? Xia Xing Yin, what must be constant? Xia 出来了，xia。xia 不见了，对啊，xia Xing Yin 跑去哪里了？Yvonne, can you come up, please? Yvonne.
Cross-sectional area of wooden block.
Yes, the wooden block, the surface area of the wooden block must be the same. The cross-section area of wooden block. Yeah. Okay, after that, table, put everything inside a table. Okay, your table should be like this. I see I got an answer here or not now. Wait now. Sometimes the answer also wrong one here, cannot use one. I think it's here. Okay, so your table should be like this. Just now the answer all correct like this or not? Is it all same? All the answers same or not? Hoa Khai, all the answers same or not?
Yeah.
All same, all same with, I mean, all these answers same as what we discussed just now.
Yeah.
Okay, thank you. Okay. Finish, Okay, plotting the graph, you all do later, do it later, you do now, okay? So the last part is a relationship. Take out this answer, it should be directly proportional. The relationship is D directly proportional to F. Okay, the answer you jot out the answer lah. The graph you do later lah. D directly proportional to the F. It should be a straight line graph lah, like this ah. Go through it's supposed to be a straight line graph. Like this, okay? So here is D. Here is force, okay? So you should get a graph like this, directly proportional graph, okay? That's why the answer is D directly proportional to the F. Graph to yourself, okay? You don't be lazy, you know. The graph, you must practice to plot the graph. You must practice to plot the graph. But here, I don't want to wait for you all to do now, okay? So you do the graph later, make sure you get the graph like that. Directly proportional graph, okay? Okay, now we look at the next question. Okay, come, follow me, everyone follow. The graph you do yourself, Question number 2, okay, follow here now. A student carry out experiment to investigate the relationship between the resistance R and the length of constant wire L. Is between the resistance and the length of wire. You already know the answer one now. When the wire getting longer, resistance is higher. Correct not? The longer the wire, the higher the resistance now. The result show on the graph. Where is the graph? The graph is here. This graph lah, okay? This graph show the relationship between okay, the graph is here. So from here you see that this is resistance. This is a length. So it's directly proportional, very obvious that the longer the wire, the higher the resistance. The graph is here, okay? So now the question asks, based on the graph, what is the relationship? Okay, the answer is directly proportional. You must write directly proportional. How you put it in one sentence? Okay, how you write in sentence? Tan Yun Su, how you write in sentence?
R is directly proportional to L.
Yes, correct. The responding variable must come first. R directly proportional to L, okay? And next part. Next, resistivity rho given by the formula rho resistivity equal to MA. M is a gradient of the graph. Okay, you find the gradient now. A is a cross-section area of the wire. So calculate the gradient of the graph. Okay. Calculate the gradient of the graph. So use a graph to find the gradient. Okay. Like that. You must show the triangle on the graph. Okay. Very simple. Use this point. Okay. Here, draw a line. Now use a ruler. Okay. Then 90 degrees. Use this big triangle. So here is 1.6. Here is 50. So the unit, please follow. Here is 1.6. The unit here is what? Ohm. Okay, this is ohm. And here 50 cm. So that you don't make mistake. Okay, 50. Follow the unit. So C gradient is 1.6 ohm divided by 50 cm. So you get the answer. So what is the answer? No, you get 0.032, okay? 1.6 ohm divided by 50. You see in the marking scheme, like you say one, no, look this graph, you have to tunjuk segitiga. You see, have to show the triangle, you know. I told you many times, or in the marking scheme in the SPM, memang like that one. Tunjuk segitiga. You have to show the triangle. This triangle must be shown. Understand? Yeah. And 1.6 divided by 50, you get 0.032 ohm per cm. Okay? Okay, huh? And the next one is calculate the values of surface area lah. Row given the question given the values already. Resistivity, right? Given. And gradient 0.032. So you calculate, you get this answer. 1 times 10 power -4 centimeter square, because it's area, surface area, so it's centimeter square lah. Okay. Okay, ah. Okay, next question. They ask you to find this one. Based on the graph, determine the value of R when the L70. Okay, you draw lah, L70 here. At here lah, L70. You must show, you know, from here, draw a line go up. You have to extend the graph lah. The graph to extend until this one 70 go up, okay, meet up here, then you see the answer. Okay, this one go up, then find the answer. Okay, so must show the line here, 70 cm, draw a line go up, this line extended the graph, extrapolate the graph, and this one go up 70. See what is the answer here? What is the answer? What answer you get? Then L70. What is this answer?
2.24.
You got 2.24. Let's see the answer now. Yes, correct. The answer 2.24. Correct. Your answer is correct. So you get this answer now. 2.24 ohm. Okay. 2.24. Okay, last part of the question. This one calculation. Using the answer 2C1, using this answer R, if one identical constant wire connected parallel, okay, using this formula, parallel one, use this formula to calculate, right? Then calculate the resistance, that's all. Use this formula, your R is just now 2.24, so you substitute, calculate, so you get this answer. Okay, come. 1.1 over 2.24, 1 over 2.24, because the resistance you calculated just now. So you calculate, you get this answer, 1.12 ohm. This one okay, Okay, last part of the question, precaution, as you know. Okay, can someone tell me the precaution? State one precaution should be taken during the experiment. Okay, your experiment is you see the graph, you are using ruler. Here using ruler to measure the length. Here are resistance. Resistance, definitely you are looking at watt meter, ammeter to find the resistance, right? R equal to VOI, correct not? So what is your precaution here? What are you supposed to write for precaution? I think someone answered already. Come, let's see what you wrote. Avoid parallax error. Jeff, your answer half correct only. Yan Ming also say avoid error, half correct, only half correct. You cannot just write avoid parallax error. Cannot. The complete answer must be what? Can someone please tell me what is the complete? What is the complete answer here? Okay, now another one type. By avoid parallax error by placing the eye perpendicularly to the skew, still not correct. To the skew of what? Take the reading by putting the eye position perpendicular to the skew. Okay, come now. Your answer given actually all are correct, but because the marking scheme is very strict, they cannot accept you say avoid parallax error by position the eye perpendicular to the skew. No more. Started 2 years ago. They want you to tell specifically the names of the skew of the instrument. Resistor what Tan Jae-yin say I must be perpendicular to the skew of vernier caliper. Yes, correct. This is correct. Because using vernier caliper this I'm not sure using vernier caliper no Jae-yin. The vernier caliper was question 1, Tan Jae-yin. This one question 2, not vernier caliper. Sorry, Tan Jae-yin is okay. You read the question 2. Is he using what instrument? Tan Yun-si say, avoid parallax error by position our eyes perpendicularly to the measuring scale of meter rule. I think this is correct. Meter rule. Okay? Meter rule. Because length, definitely here, the length of the wire, how long the wire, isn't it? Here use ruler one. Here, resistance, you cannot measure resistance, but you measure the current, measure the voltage, then you calculate. So you must say parallel to the scale of wattmeter, or the scale of ammeter, or the scale of meter rule. Understand? Okay, please write the answer correctly. You write the answer, then I want someone to read out the final complete answer. Yvonne 可以出来吗 Yvonne
The eyes of the observer must be placed perpendicularly to the scale of meter rule to avoid parallax error.
Yes, correct. Okay. Yvonne 可以再读多一次吗？慢慢的。Yvonne?
The eyes of the observer must be placed perpendicularly to the scale of meter rule to avoid parallax error.
Yes, correct. This answer is correct. Okay. You must mention specifically the skill of what instrument. The latest marking scheme, they want you to mention the name of the instrument one, Last time you just say perpendicular to the measuring skill can already, but now no more. Must give the correct answer. Tan Yun-si, Tan Yun Su, can you read your answer? Yun Su? Okay, read your answer slowly.
Avoid parallax error by position our eyes perpendicularly to the measuring scale of meter rule.
Yes, correct. Okay, you can either say meter rule or watt meter or ammeter. Okay, all right. I think that's all, Okay. So finally, we have finished up this paper already. Okay. Next week I will give you a new paper, I think I will send you all. You have to print now. What to do? Is it possible you all come over to take? You all want to come to the center and take or not? I want to ask you all. I set a time you all come and take, can or not? But I don't want too many people come at the same time, then later kena saman, Other tuition also like this, Okay like this, I think I will forstate the paper. I fix a time, you all go and collect, but please don't come at the same time. Understand? I will let you know, Okay? Most probably Saturday, Sunday only, Saturday, Sunday only, I will be there. Wait for you all. You all come and take the paper, Okay? Okay, So that's all for tonight, Okay? So take good care of yourself. Continue to study, understand? What time I will let you all know, No, most probably is Sunday, Sunday, I think your parents also not working night. Only got time to come and take my Sunday. Okay? I will put in a WhatsApp what time you all come to collect the paper. Okay? All right. And then your fees, you all pay online. Everybody, you all want pay fees, pay online. Thank into my account number, Okay? All right. So take good care of yourself. Don't go out. If possible, you don't need to go out, Stay home, study. Okay? Study as usual. Must take good care of yourself. Don't fall sick. Okay? All right. That's it. Okay. Bye-bye, everyone. Bye-bye.
Thank you, teacher. Thank you, sir.
Okay. Bye-bye. Bye-bye.
Thank you, sir.
Okay. Bye-bye.
Thank you, sir.
Thank you, sir.
Okay. Bye-bye.
Thank you, sir.
Bye-bye. Bye-bye. Yeah.